The following is the video solution from JSDT Solutions. Question 7.1 says P, Q, R, S, and T lie on the circle with center O. PR is perpendicular to OQ, and these two lines intersect at F. POT is a straight line, and angle P1 is equal to 42 degrees. Okay, so if POT is a straight line, you can see that this is a diameter since it passes the center of the circle. Okay, and question 7.1.1 says, determine given reasons the sizes of the following angles. And they first want us to find the size of angle R1. Okay, let's look at angle R1. Angle R1 is over here. So it's at the circumference, and you notice that angle R1 is being supported by this diameter POT. So it means that the size of it is 90 degrees because it is supported by a diameter. So we can tell them that angle R1 is simply equal to 90 degrees. And this is because we have an angle in a semicircle. Okay, and that is our answer. Moving on to the next question. Next question B says find the size of angle S. So remember that angle R1 is now 90 degrees. To find angle S is at the circumference. Okay, so we need to apply rules about angles at the circumference. But you notice that angle S is supported by RT. Okay, you can say the chord RT. You can also say the major arc RT. Now, we don't really have any other angle that is also being supported by this major arc. So we can't really apply rules about angles in the same segment, or even angle at the center is twice the angle at the circumference. But do you notice that if you go from angle S and you join 4 points on the circumference of the circle, so to R, P, and T, we have a cyclic quad. And what do we know about the opposite angles of a cyclic quad? They add up to 180 degrees. Okay, so it means that angle S will be found by saying 180 degrees minus 42 degrees. So that's how we'll find angle S. We'll say 180 degrees minus 42 degrees. And this is because of opposite angles in a cyclic quad add up to 180 degrees. And this is finally equal to 138 degrees. And that is our answer. Moving on to the next question. The next question C says we need to find the size of angle PQR. Okay, so we know now that angle S is 138 degrees. And now how do we find the size of angle PQR? So this angle over here. Okay, it's also an angle at the circumference, but it's quite big, and again, we can't really see any other angles supported by the same chord or that major arc. So let us join 4 points. Okay, so here we can join till T and then to P. So we have a cyclic quad again. So in order to find angle Q, and you can just check the mark allocation for this. This is 3 marks, okay? So it wouldn't be the same steps, the same one-step process like the previous question. So if we want to find angle PQR, we would have to find angle T2. So let's go ahead and find angle T2 first. Looking at this, angle T2 is actually part of this triangle PRT. And you see that it's the only angle missing in this triangle. So we can find it. We can say 180 degrees minus 90 degrees minus 42 degrees. And that will give us angle T2. So let's find angle T2 first. Angle T2 equals 180 degrees minus 90 degrees minus 42 degrees. And the reason is the sum of angles in a triangle. So therefore, angle T2 is equal to 48 degrees. Okay, now that we know what angle T2 is, how do we find angle PQR? So again, using that cyclic quad, you see that the opposite angles of a cyclic quad add up to 180 degrees. So we can simply say that angle PQR would be found by saying 180 degrees minus 48 degrees. And that is because of the opposite angles of a cyclic quad add up to 180 degrees. So therefore, angle PQR is equal to 132 degrees. And that is our answer. Moving on to the next question. The next question, 7.1.2 says, if PR is 7 centimeters, QR is 4 centimeters, determine the length of QF. Okay, so let's look at this in our diagram. Okay, so looking at our diagram, knowing that we found this to be 132 degrees, they tell us that PR is 7 centimeters. So this over here is 7 centimeters. And then QR is 4 centimeters. And we need to find the length of QF. Okay, so how would we do this? Okay, so do you notice that they're giving us the dimensions that will help us with this right angle triangle we have here? They want us to find QF, but they've given us QR, and they gave us the entire length of PR. So we can simply just find this side, RF, and we would be able to find QF. Okay, so to find RF, do you see that we have a line from the center of the circle perpendicular to the chord? And so that line will bisect this chord. So let's go ahead and start off there first. We'll tell them that FR is equal to FP because of the line from the center of the circle perpendicular to the chord. Okay, so since those are equal, it means that if this entire length is 7 centimeters, then each of them are 3.5 centimeters. So we can just say that is going to be 3.5. Okay, so let's just conclude what FR is because that's what we're trying to find. Therefore, FR equals 3.5 centimeters. And now we have everything to find QF. Okay, so using the theorem of Pythagoras here, you can see that QF is one of the shortest sides. So we'll say QF squared is equal to the longest side, QR squared, minus the other shorter side, FR squared. Okay, and the reason for this is the theorem of Pythagoras. So we can just tell them it's because of Pythagoras. And now we can just find QF. So we'll say that QF squared is equal to, they told us the length of QR. It's 4 centimeters. So that's 4 squared minus FR squared, which is 3.5 squared. Okay, so let's go ahead and just find out exactly what this is. Okay, so at this point, you can just go ahead and square root both hand sides. So on your calculator, you'll find out what the square root of 4 squared minus 3.5 squared is. And that will be the length of QF. Okay, so looking at that, rounding off to 2 decimal places, you see that that 6 is going to round that 3 up to a 4. So QF is equal to 1.94 centimeters. And that is our answer. Moving on to the next question. Question 7.2 says, in the diagram, B, D, and C lie on the circle with center O. AB and AD are tangents to the circle at B and D respectively. And we're also told that angle BAD is 59 degrees. Okay, determine, given reasons, the sizes of each of the following angles, and 7.2.1 says we need to find the size of angle B1. Okay, so let's look at where B1 is. So B1 is over here, meaning it's between a tangent and a chord. But the thing about this is we can't really use the tan-chord theorem here because the angle between the tangent and the chord is equal to the angle supported by that same chord. So the angle supported by that chord is angle C, which is empty right now. And we can't really say, okay, we can find angle C by saying these are opposite angles because that's not a cyclic chord, okay? This is outside the circle. So we could use that we have a triangle here, triangle ABD, okay? So, and it has this angle. Now, when we have tangents drawn from the same point to a circle, those tangents are equal, okay? So it means that line AD is equal to AB. And so this is an isosceles triangle. And so we will be able to find these two angles since we have one of the angles in this triangle. Okay, so let's go ahead and start by telling them that AB is equal to AD. So AB equals AD, and the reason why is because tangents from the same point drawn to a circle are equal. Okay, tangents from the same point are equal, and now we can go ahead and tell them that these two angles are equal. Okay, so angle B1 is equal to angle D1. So we're concluding that angle B1 is equal to angle D1. And the reason they are equal is not just because this is an isosceles triangle, it's because these sides are equal. And so the angles opposite their equal sides are also equal. So we can tell them that. Okay, and so now that we know they are equal, let's go ahead and use the sum of the angles in a triangle, seeing that these two are exactly the same. Okay, so we can go ahead and tell them that angle A, which is 59 degrees, so 59 degrees plus angle B1 plus angle D1, that they add up to 180 degrees because they're the angles in a triangle. Now, we already know that angle B1 and D1 are equal, but we're trying to find angle B1. So in place of angle D1, we're going to replace that with angle B1 since they are equal. So that's angle B1 equals 180 degrees. So now this is 2 angle B1. Okay, it's double that. And then we'll say 180 degrees minus 59 degrees. Okay, so 2 angle B1 is finally equal to, this will be 121 degrees. And then we'll have to divide both hand sides by 2 to finally solve for angle B1. So it means that angle B1 is equal to, and that's going to be 60.5 degrees because 120 divided by 2. Okay, so angle B1 is equal to 60.5 degrees. And you can fold this in your diagram just in case it helps you with the next calculation. Okay, moving on to the next question. Question 7.2.2 says find the size of angle O1. Angle O1 is at the center. Okay, so it's at the center. Let's use theorems that have to do with angles at the center. So the angle at the center is twice the size of the angle at the circumference as long as they're supported by the same chord or arc. Now, right now with this angle at the circumference, we don't have anything there. But do you remember that this angle over here, right? This is the angle between a tangent and a chord, so it's equal to the angle supported by that same chord. So over here, this would also be 60.5 degrees. Okay, so let's go ahead and tell them that angle C is equal to angle B1. Okay, so angle C equals angle B1, and this is because of the tan chord theorem. So it means that angle C is also equal to 60.5 degrees. And now that we know angle C, we can go ahead and use that to find angle O1. So angle O1 is double the size of angle C. So it means that this is the larger one. So we can go ahead and say angle O1 is equal to twice the size of angle C. And so this is because of the angle at the center being twice the angle at the circumference, as long as they are supported by the same chord or arc. And so angle O1 is equal to twice of 60.5 degrees. And you see that this takes us back to 121 degrees. And that is our answer. And that is it for question 7.